Let's revise the DX7 envelope generator. There are 8 parameters for each operator. Rate determines the speed of an envelope, and level determines the amount of an envelope applied. The DX7 envelope generator is more flexible than a traditional ADSR envelope, as you can use both rate 2, level 2, and rate 3, level 3 as part of decay or sustain. Let's go over how envelopes are used for all operators. We know that the tube bells has faster attack rate, which reaches to the maximum at level 1. For operators 1, 2, 3, and 4, they have the bell inharmonic tone, which has slow decay. For operators 5 and 6, a hammer tone is produced with faster attack rate and faster decay rate. We can ignore rate 3 and level 3 as they are redundant. We will visualize how these envelopes are generated. For operators 1, 2, 3, and 4, their envelopes are very similar. They have faster attack. They have a slow decay, slowly reaching level 2, which is 0. This means that they only have one decay, which is controlled by rate 2 and level 2. Although, when you press a key long enough, their envelopes reach rate 3 as level 3 is 32. You only hear very faint sustained sound. So, rate 3 and level 3 are redundant. For operators 5 and 6, their envelopes have fast attack and fast decay. They quickly reach level 2, which is 0. So, they have one decay, which is controlled by rate 2 and level 2. As these envelopes stop at rate 2 and level 2, rate 3 and level 3 are not required. For those who are new to the FM synthesis and the DX series synthesizers, I recommend that you pause this tutorial here and revise the envelope generator if necessary. If you require, you can go back and revise the tutorial Sound Design Tube Bells Part 2. Also, you can revisit self-learning tutorials. When you are ready, you can proceed. Now, we will look into keyboard rate scaling, output level, and key velocity sensitivity. Press buttons 26, 27, and 28 and use operator select button to cycle through all operators. Let's start with keyboard rate scaling. It determines how fast an envelope moves from rate 1 to rate 4 based on a key position. So when you press lower keys, an envelope moves slower, and when you press higher keys, an envelope moves faster. The table shows all 6 operators are set at 2. The maximum is 7, so there is a bit of speed up at higher notes. Now, we can look at output level. It determines the level of modulation for modulator and volume for carriers. For carriers, they are usually set over 90 to get maximum volume. For modulators, usually over 90 is too high as you start to create unwanted harmonics and inharmonics as well as noise. So between 70 to 90, modulator generate enough frequency modulation. Now we have an important parameter for controlling expressiveness of the DX7, key velocity sensitivity. It controls the amount of volume for carriers and the modulation for modulators based on the speed of a key pressed. This is very interesting since only operator 5 is set at 5. You can press a key faster or slower, but the overall tube bell's sound does not change at all. Now, it's a good time to revise what we've learned so far. The tube bells uses algorithm 5 with 3 independent towers acting as additive synthesis units. Towers 1 and 2 have the same bell inharmonic content at ratio of 3.50. Towers 1 and 2 are detuned to give a smooth chorusing effect. Towers 1 and 2 have the same envelope. Tower 3 is for attack but very quiet. Keyboard rate scaling is applied slightly to all operators. Output levels are adequate, producing enough modulation at maximum volume. Finally, key velocity sensitivity is applied only to operator 5, which controls the volume of attack. The overall dynamics and expression is missing. You can pause here to do self-learning tutorial. Turn on operators 1 and 2 only. Adjust output level of operator 1 down to 70, 50, 30, and 0. How do these changes affect the overall tone? Put operator 1 output level back to 95. Select operator 2 and change its output level down to 70, 50, 30, and 0. How do these changes affect the overall tone? Repeat the same process for operator 5s and 6. How do these changes affect the overall tone? Also check low priority parameters such as LFO and see how they are used. Note that some of these parameters have not been used for the original tube bells patch. Once completed, think about how you may be able to improve the tube bell's sound and still retain its original tonal characteristics. Consider which priority parameters you need to change. If you need further revision, please do so before proceeding to the next tutorial session. If you haven't subscribed yet, then please do so here. When you are ready, you can go through the tutorial, FM synthesis sound design, tube bells improvement. We will look into how we can improve the famous factory patch.